Yeah, hi everyone. My name is David, and today I'll be introducing something that we've spent the last few months working on, and that I'm particularly excited about, and that is a performance deep learning solution to tabular data. And this will be in the same style that Tarun just mentioned of the push button classifier type. So we'll start with an introduction, just for those who are not familiar. What is a tabular data problem? So surely you've seen some data set like this. They'll have some columns, maybe some categorical information, numeric information, and you'll have some objective, maybe in the form of a label that you want to optimize for. So the point is here that this type of data set is pervasive across several industries. This is the most common type of data. Dump it into a simple relational table. Has applications in many industries such as financial services, also healthcare, climate science, and it's even wide-reaching in sorts of like Kaggle data sets. You'll see this a lot all the time in those competitions. So the point is here that solving problems like this has wide-reaching applications in all sorts of different domains. But how do we go about solving these types of problems? So if you're familiar with, again, the Kaggle competition scene, you'll know that tree-based models like XGBoost are the standard for these problems. You'll see these types of models at the very top of the competition leaderboards. And sometimes there are some deep learning models that also reach the top, like, for example, TabNet, that have attempted to beat these tree-based models, but in general, they often fall short. And so the point is here that we set the stage that there's, for such a common model and a common problem, having this tree-based model as a top method is not ideal. And part of the reasons why are that deep learning solutions have several influential paradigms that are simply not possible with trees. For example, transfer learning, semi-self-supervised learning, and data parallel training. These things are things that deep learning is very good at, and which trees are not. And so that leads to the question, is there a wide-reaching deep learning solution to the tabular data problem? That also includes that AutoML type of capability. And we're excited to announce that with we've received some very exciting results that, enabled by our Bolt engine and enabled by our sparsity knob, we've introduced the Bolt tabular classifier. So this is a push button classifier. Everything's auto-tuned and it reaches near state-of-the-art accuracy right out of the box with minimal hyperparameter tuning. You'll see some of these results here that we've benchmarked on several tabular classification data set where we match or beat XGBoost and TabNet out of the box. And so the advantage of this is that it's much easier to train, and you get similar performances, if not better than these other models. So this is promising. So another thing that is incredibly important that we've mentioned here is this sub-millisecond inference. So this right here is about 20x faster than XGBoost for single sample inference, which definitely makes an impact for downstream applications. So now that being said, let me go ahead and share a quick demo. So yeah, I'll go ahead and show you guys how easy it is to use something like this Bolt tabular classifier. So let's start off by, let's start off by downloading our data set. So let's run this and download that. So yeah, so as we've mentioned, defining and training this tabular classifier model is incredibly easy. As you can see here, I've passed in a model size to the input, and that allows you to train with a certain size, maybe medium, small, or large, medium, small, or large, and maybe pass in some size in gigabytes, and you can train simply by passing in the CSV file. And so we've reached about 85% accuracy in just 2 epochs in a little under 20 seconds here. So this is great. This already matches what XGBoost gets on this accuracy out of the box, or on this data set out of the box, which is great. But let's first show how we can predict on this data set, and we'll see that we've received an 85% accuracy on that on the test set, which is great again. And then just to showcase the single sample inference time, we've simply defined a list of values here corresponding to a row, and we're going to use our optimized single inference method here, and we'll show that we predicted a class in well under 1 millisecond, which is again 20 times faster inference than XGBoost for single inference. So with that being said, I'm gonna thank you guys for listening, and I'll pass it on over to Jordy, who's going to be talking about our push button sequential class.